All right, today we're talking about how to graph absolute value functions. So we already know how to graph a linear function. Absolute value is very similar, which is why we kind of lump them together. These notes are long, but it's really, we're combining your notes and assignment together essentially. So throughout your notes, I'm going to do the highlighted ones with a yellow dot, and then you'll do the ones that don't have a dot. So you can choose how you want to do this. You can watch me do one and then do the similar one and just pause and do it right then. Or you can watch all of the ones I do and then go back and do the blank ones. Okay, but the blank ones are going to be considered your assignment for today. So this says make a t-table and sketch the graph of f of x equals the absolute value of x. So if I'm plugging in these values into our absolute value, the absolute value of -3 is 3. I have 2, 1, 0, 1, 2, 3. Okay, really it's the distance between that number and 0, which really just removes the negative sign. They'll all be positive values because distance is positive. This graph changes directions at the origin. Not all absolute value graphs change direction at the origin. The location that any graph changes direction is called the vertex. Okay, so they will all change direction. They have a V shape. So let's go ahead and plot this one. -3, 3. So this one would look like so. So absolute values are V-shaped. They all will be. This one does start at the origin at 0, 0, but they don't all. So this one starts at 0, 0, the vertex. That's where it bends. And then the slope for this one is up 1, right 1, or a slope of 1. Now this is a slope of -1, this is a slope of +1. I'm just going to give the positive 4 of our slope. Okay, so here, these graphs undergo transformations just like lines and any other function we'll learn about. So based on what we know about transformations, predict the graph or equations. So here, it's whatever my value is plus 3. Okay, so really what that means is, like if I plug in a 0, I'm going to have 0 plus 3 is 3. So I'd have 0, 3. If I plug in a 1, 1 plus 3 is 4, so that's the 0.14. And I would get the same thing if I plugged in a -1. If I plug in a 2, 2 plus 3 is 5, or 2, 5. And I'm going to get the same thing if I plug in a -2. So if we extrapolate this, really all we've done here is our vertex has changed to be 0, 3, and our slope is still 1. Okay, so now you have a couple choices. You can pause and do this one right now, or you can keep going with me and do it at the end. All right, so moving right along down here, it's already graphed for us. We're going to try to predict its equation. So its vertex is down here at 0, -6, and its slope is still 1. So if we compare it to this one, this plus 3 moved it up 3. It slid or translated up 3. So if I want it to slide down 6, I would use a -6. Okay, that's the only thing that changed, so it's the only thing we have to add on the end. Okay, and then this one right next to it would be part of your assignment today. All right, it says check these with Graphing Calculator or Desmos. Based on what you know about line transformations, predict the graph or equation and then check. All right, so I have Desmos pulled up here. It's just desmos.com so that I can type in what it's asking. So g of x equals 3 times the absolute value of x. So, and then you can zoom in, out, whatever you need on these. So it looks like I do start at the origin at 0, 0. And then I have a point here. Looks like we'd have a point at 1, 3. Here, let me change my settings here. I want this step to be 1 so that each line only means 1. So it'd be a good idea for you to change that also because it's easier to see that way. So I have a point here at 1, 3, and negative 1, 3. Okay, so if I connect these, in this case my vertex is 0, 0. It does start at the origin. But my slope is up 3 over 1, up 3 over 1, up 3 over 1. So this line is, when I drew it, I wasn't very careful. So it'd be slightly off, okay? My slope is 3. All right, so when you have a number in front of your absolute value, it changes the slope. All right, so again, this one right here is part of your assignment. J of x, again, it's graphed for us, and we're going to try to write the equation. So its vertex is 0, 0, just like the one above. And then it looks like this would be a point. This would be a point. So that would be up 2 over 3. My slope is 2/3. So I would write that with 2/3 in front of my absolute value of x. Okay? And again, this one would be part of your assignment. Okay, try these based on your line background. So this vertex is at 0, 0. But as you can see, this is flipped upside down. So let's look at its slope. It looks like if you go right 1, down 1, right 1, down 1, or left and down, left and down. So it looks like our slope is 1. So I'm going to try putting that into Desmos. But when I use a slope of 1, here, we can even zoom out here, my absolute value shape is still upwards. Okay, so my other slope I was getting down and right would give us a -1, and that is what's going to flip it upside down here. Okay, so our slope is actually for this one -1 because it's upside down. So this would be -1 before your absolute value of x. Okay, so that's how you get them flipped over with a negative coefficient. All right, so a combination. This means that our slope in front, we already discovered that our slope will be 2. This -9 at the end tells us that we're going to translate or slide down 9. So I know my vertex is going to be 0, -9. And then my slope is going to be up 2 over 1. So we've already discovered those things. Now we're just putting them together here. Okay, and absolute values do go on forever. So just like lines, your picture should extend in all the space you have with arrows on the end. All right. Here's a new transformation. Okay, we haven't done one where the minus is inside the absolute value. We've only done them where they're on the outside. So I'm going to go ahead and use Desmos again. This time we have r of x and x minus 5. I'm going to zoom back in here. So it looks like I start at 5, 0. Right here. And that my slope is 1, up 1, right 1, up 1, right 1. So when it's on the inside of your absolute value, that's how many you move over, right or left, but it's the opposite. I didn't go over to -5, I went over to +5. So it is the opposite sign when it's on the inside here. But if you're ever confused on these, your best bet is to always just make a table and see if you can figure out what's happening. Even just pick a few 3 values to get some points, and that'll help. Okay, so again, any that I skip here are your assignment. Okay, so this is trying to put together a lot of stuff we just learned. So if it's on the inside, that's moving it either right or left, but it's the opposite sign. So this -2 actually means that we're moving right 2. This plus 7 does mean we're moving up 7. It's just whatever sign it is. It's not the opposite. And then this negative in the front is really a -1. So our slope is -1. So I'm going to start at 2, 7. And then I have a slope of -1. Okay, so that would be my picture. And again, you want to check yourself. Feel free to type it in, especially while you're learning. And their picture does match my picture. Okay? Okay, again, I would use Desmos to check instead of relying on it to graph everything for you, because you're not going to be able to use it on a test. So Desmos is a great tool, but I wouldn't rely on it too heavily. So like this one, I would try to graph it yourself and then check it in Desmos. All right, very last page of our packet, we're going to fill this in. A, any number in front of your absolute value is the equivalent of slope. Okay, that changes your slope. It is a rotational transformation. It rotates the angle of your V. If A is negative, then the transformation is also a reflection. That's where it flips it upside down over the x-axis. X minus h acts as a horizontal translation. To find the horizontal translation, set x minus h equal to 0 and solve. So like if you have x minus 2, for example, that means that x is going to be a positive 2. Or you can think of it as just the opposite sign. K is the vertical translation, and it's just whatever sign it is, okay? So inside your horizontal translation, it's the opposite sign. For the vertical translation on the outside, it's just the same sign it already is. All right, and so again, you don't have a separate assignment tonight. Your job is just to go back and do any of the graphs we skipped, which is pretty much just the right column of the last 3 pages.